Okay, so this is my first trying to solve the geometry problem. Uh, so I wish everyone can just at least for the algebra you need to learn at least the first 6 chapters of the intro to algebra, because for geometry I will not talk about anything about algebra. I suppose you can solve all the equations and know all the relationships very quickly. Okay, the focus is only on the geometry. Okay, now the first question. So the measure of the two angles of an isosceles triangle. So we have iso triangle. This is iso triangle. It's ABC. Okay. So we have the two angles, right? So what's the possible values? So the first is the vertex angle, right? So it's 3x plus 4 is this, and the base angle is x plus 17 and the x plus 17, right? So there is a second possibility is you put the x7 plus 17 is the vertex angle, and the two base angle are the 3x plus 14, right? So basically we have two cases. The first case is 3x plus 4, 3x plus 4, and x plus 17. The second one is x plus 17, x plus 17, and 3x plus 4, right? So you can just try to solve equations. So here we'll have the 7x plus the 8, and it's 25 is 180, and here you have the 5x plus the 38 is equal to 180. So you can solve this one. X is equal to 7 over 160, 155. Yeah. And for the second one, you can see x equal 5 over minus 40, 140 is 142. Okay. So this is the answer. Okay. So for second one. Okay, so you see I already draw some pictures because draw picture takes time. Okay, so let's talk about it. So I have a equilateral triangle. Okay, let's notate it as equilateral triangle. Okay, then it's we get the square on all the sides, right? So you can see the square ABDE will be congruent to the square of the ACIH, also congruent to the square of the square, okay? And also the congruent to the BC GF, okay? So this, when the goal is to prove triangle, okay? Goal is to prove triangle DHF is equilateral triangle. Okay, so yeah, this one is basically it's very simple. Okay, let me connect some lines, and I will explain why I connect all these lines. Okay, these are the auxiliary lines. Okay. Right, so the concept is this. Okay, so in order to prove the triangle is equilateral, right? So we need to prove. Okay, this is how we're thinking. Okay, and when you write, you need to write opposite. Okay, so we need to prove that DH equals HF equals DF, right? So when we prove the sides, when we want to prove the sides, right? Sides is hard to see. Okay, we always want to find congruent triangles, right? So how we can find those congruent triangles? Okay, so let's see. So we are talking about the DH and the HF, right? Okay, so let's see what's the triangle here. Let me change another color. Yeah, so geometry is pretty annoying, so I need to show colors to show you the triangles. Okay, so you can see if I want to prove, if I draw a triangle of this and I have another triangle of this. Okay, so what you can see here, if I have a triangle, oh, I'm sorry, if I have triangle DHA, okay, I will prove this one DHA congruent to triangle HFC. Okay, so how we can see it? Okay, the two congruent congruent triangle, you either have three roots, SSS, SAS, or the AAS, right? Or this one equivalently ASA, right? So now let's see. So you can see here is HA, right? This one is sides of the A, right? So this one is also sides of the A. These are all the A's. Did you see? The equilateral triangle tells you AAA, and the extension is the square, so it's the all A, right? Did you see my red lines? My red line is diagonal of the square, right? So this is the root A, root 2A, right? So they are still equal, right? So now, in order to prove this, we already proved the two sides, right? So what we want to prove is the angle here is equal to the angle here, right? So what's this angle? This angle is 45 degrees, right? So you can see, let me show you something, okay? Very simple, okay? So you can see here. So I have a 90 degree here, and I have a 90 degree here. I have 60 degree here, right? This is a cycle, right? So this one is 120 degrees, right? So now you can see, go up to C, so you can see this angle is 120 degrees, okay? And this one is 45 degrees, right? So you know, let me write here, you know that DAH is equal to 120 plus 45, and the same reason you can see angle HCF is equal to 120 plus 45, right? Now you have what? You have the to prove this, you have the HA equals, you have the HA equals the FC equals A, right? Okay, you have the DAAD equals the HC equals root 2A. Then you have the angle HCF equal DH. Angle HCF. I'm sorry, you should be writing the other way. Yeah, I cannot see both page. You know, I have to scroll up and down. So it's angle, okay, HAD. Angle HAD equals angle HCF. HCF equals 165 degrees. So this is the Sas rule. Then you can see that these two triangles are congruent, right? Then you can have the H is HD. HD equals HF. Okay. So the same on the other reason, right? You can see there is another congruent triangle. Okay, let me show you here. So that's this one. Okay, so basically, let me write here. Okay, you have the FD B congruent to triangle DHA congruent to triangle DHA HFC. So that's why you have DH equal HF equals DF. Then this one you can see triangle HDF is equilateral triangle. Okay, next. Okay, so again I have to draw the picture first. Okay, so you can see it's the ABCD is a rectangle. Then you construct erected. Okay, this is those things we call the erect triangle. Okay. Erected means you go outside or towards inside. It doesn't matter. Just from one side, you do the equilateral triangles. Okay, so the this one is, for example, this one is A, this one is the B, then this is B, this is A, right? They are equilateral triangles, and yeah, externally on sides. So prove the triangle DEF. Prove triangle DEF. Again, I mean DEF, right? Go. Triangle DEF is equilateral. Okay. So thinking, no difference. ED is DF is EF. Okay. Then how to the way? Congruent triangles. Okay, so now let's see. The first, if you want to find the goal of the triangles, first, okay, this line, this sides, and this sides. Okay, 3 sides, right? Okay, so we need to find congruent triangle, right? You know this one is equal to this one, right? So this one is also A. So it's very clear. You can see, let's draw one triangle. That's using these sides and using these sides, right? So you already have these 2 triangles. You already have the A and B, right? You already have A and B. So the rest of thing is to prove this angle equals this angle. It's very obvious, right? This angle is 90 plus 60, right? This angle is 90 plus 60. So you can have, so that's why you can have triangle EAD congruent to triangle DCF is Sas Rule, right? So now you have the ED equals to the DF. As the same way, you can have the triangle EBF congruent to triangle DCF. So you can also have the EF equals DF. Then combined together, you can see triangle EDF is equilateral triangle. Okay, that's it. Next. Okay, so what we know here, okay, so ABC is a right triangle. It's right. Okay, so we have right angle. Let's notating something is that's notating is the A plus B equals 90. Okay, so you can think, okay, so we have the AC equals AD. Let me use another color. AC AD. Okay, and we have the BC and BE. Okay, so let's parameterize this angle. Okay, so let's see this angle is let's see this angle. Okay, this angle, because the BCE is the equilateral triangle, right? So this one is 90 minus B over 2. Okay, So ACD is the equilateral triangle, right? So this angle equal to 90 minus A over 2. Okay, so this angle is the external angle of this two. Okay, I'm sorry. Yeah, once we have this, we want to solve the angle is DEC, right? So the angle DEC is equal to 180 minus the angle CED minus the angle CDE is equal to the 180 minus the 180 minus A over half, and the half of the B is equal to A plus B over 2. What do we have here? 90, right? So it's 45. That's it. Next. Okay, so I have to draw the picture here. So here is the square ABCD, and inside we have the AE, DE, and the DF equal the AD and the CD, and also we have all the angles are the same, right? So we need to parameterize it, okay? Parameterize is A and A and A and A. There are several equilateral, the isosceles triangles, and we have the 30 and the 30 and 30. So we can calculate in some angles. This is a 75, this is a 15, right? And this is the same thing, this 75. Okay, so what we want to prove is EFB is equilateral, right? Again, okay, prove BE equals BF equals EF, okay? And again, congruent triangles. Okay, you need to find those congruent triangles, okay? Now it's really simple now, okay? Let me give you some auxiliary lines, okay? Because why I think about this auxiliary lines, first you need to see, okay, the AEFC, okay, so DADEDFDC, okay, they are on all the A's, right? So the AEFC is on a circle, okay, with the center of D and the radius of the A. Okay, so basically these 4 points are concyclic. Okay, when you learn the circle, you will see very important are these concyclic things. Okay, why I can think of adding these two lines, okay? Because you give me the 30 and 30, I know it's 60. Okay, 60. I know this one is 60, right? 60 and 60. 60 and 60, the vertex angle of the 60, but it's also the isosceles, because AD is equal to the DF. So that's why this is the equilateral triangle. Okay, so triangle ADF and the triangle EDC are equilateral. Okay, if they are equilateral, so you can see this is the A, this is the A, this is the A, this is the A, right? And also you know this angle is 15, because this angle is 60, 75 minus that is 15, this angle is 15, this angle is 15. Okay, so once I'm notating all this, now you can see everything. Okay, it's very simple to prove the EF equals the BF using the triangle ECF is congruent to triangle BCF, right? 15, 15, angle, angle, right? A and A, right? And the common sides, right? So I won't write it. Okay, you guys need to see. EC equals BC, right? The CF is a common size to this triangle and this other triangle, right? And the angle 15 to 15, okay? So the rule is called SAS, okay? So that's why you have the EF equals BF, okay? On the other way, you can do this one, okay? Triangle, FAE congruent to triangle, BAF, FAE, BAE, okay? So it's still SAS. You can see the EB equals EF, right? So here you can see triangle EBF is equilateral. Okay, that's it. Next. Okay, so it tells you some equal sides, right? Let me draw it for you. Let me highlight the equal sides first, okay? So we have the AF, okay, equals the AD, equals the GC, equals this one, CE, equal this one, equal this one, and equal this one. Okay, you have a set of equal sides, right? The question is asking us what is the x angle, right? So this one still, I mean, you can use a lot of the there are so many isosceles triangle or congruent triangles, right? If I have an isosceles triangle, right? If my vertex angle is x, right? So this angle is 90 minus x over 2. Basically, you can just do this, right? Isosceles, this one equal this one, this x over 2, so this 90 degrees, so that's why. So we need to parameterize all this, okay? So the first is this ADG, okay? Did you see the triangle ADG is a what? Is isosceles triangle, so here is x, two base angles, right? And the AFE is also isosceles triangle, so this is also the x, okay? This is the first thing we need to do, okay? Then let's talk about the second one, okay? So the second thing is, so you can see this triangle, the ADG, is really congruent to triangle AFE, right? Okay, because I mean they are isosceles triangle and with the common sides, right, and the base, so their vertices is equal, right? 180 minus 2x and 180 minus 2x. Okay. Now let's still try to propagate more. Okay. Try to figure out what's the relationship. So this is the 180 minus 2x. So what's this angle? So this angle is 2x, right? Because it's a line. Then this angle is also 2x. Okay. Now let's see another congruent. Okay. I will say so let me see. Okay, so we have this one is this one equal this one, right? So triangle BGD, okay, is isosceles triangle, right? So you can see if the GDB is 2x, then this angle is also 2x, right? The same thing. Okay, this is the 2x. The same thing for the triangle ECF, right? So this angle is also 2x. Okay. Now we can see. Okay. Now we can see in the triangle. Now we can see in the triangle CEA and the triangle BGA. Okay, so CEA is angle X and angle 2X and a CE opposite to the X angle, right? And the BGD, we have angle X and angle 2X, and we have BG is also opposite to X, right? So according to the AAS, right? So these two triangles are congruent, right? These two triangles are congruent. If these two, these two triangles are congruent, means this angle is also equal to this angle, right? But let's see what is this angle. Okay, this angle is the CEB is the external angle of the CEA, right? So it's equal to x plus 2x equals 3x. So because the CEB is also as let me draw it. Okay, so this thing you need to take a look at this triangle. Okay, okay, so this angle is equal to this one plus this one, right? That's 2x plus x is 3x. Okay, and because the CBE is all isosceles triangle, right? If CBE is isosceles triangle, CBE is an isosceles triangle, so this is also 3x. So this angle is x, this angle is x. Now see, we parameterize everything using the x, and finally we have an equation of the A, B, C, x, 3x, 3x. So 7x equals 180. That x equals 180 over 7. Okay, next. Okay, so this one, let's see. Okay, so we have a diagram and we know the ED is parallel to the YZ, and we know the angle DZE. The DZE, this angle that's parameterized, is equal to EZD, EZY. So here is the angle bisector, and the CYE and AYE. This is the beta, and this is the beta. Okay, so basically they are the angle bisector, two angle bisectors. Then we want to prove the CD is equal to the DZ minus the CY. Okay, see, DZ, that's marking these three. Okay, CY and the CD, they are not in a triangle yet, right? So it's hard. I mean, for anything we want to convert in the problem into the triangle. So let's do something. Okay, so first, I mean, the goal, try to convert into a line. Okay, so you can see the CD is equal to the ED minus EC, right? So can we construct some relationship of the DZ and the CY with this line, right? Let's see. So we have the ED parallel to YZ, and the cutting line is the EZ. So here you can see this is alpha, right? And we have the ED parallel to AY, cutting line is EY. So you know this angle is beta. This angle is beta. So this angle is beta minus alpha, right? Okay. So if you see let me change another color. Okay, if you see this angle is alpha and this angle is alpha, right? Means the DZ is equal to ED. Is that great? We're already converting this line to the line with the ED, which is the same line of the CD. So you can easily construct it how to calculate the CD. Okay, that's great, right? Okay, now that's the rest of thing is we want to see what is the CY versus the EC, right? Okay, now let's see. Let's do further analysis. Okay, so this is the if we can prove, okay, if we can prove if EC wants to equal CY, means this triangle should be equilateral. I mean, it should be isosceles. Okay, this triangle should be isosceles. Let's see. Yeah, of course. That's we after our parameterize, we see it's already the isosceles, right? Because here is the angle of the beta. Here is the angle of the beta. So we have the CE equals CY. Okay, so this one, DZ equals this, CE equals the CY. So of course CD equals DZ minus CY. Okay, next. Describe the SSA. Okay, SSA may not be congruent. Okay, maybe may not be. Let's see. Okay, let me show you. Okay, here is the AB. Okay, the angle A is a constant angle. Let's say alpha. Okay, instead of this, AC is congruent, right? Let's see, this is also X and Y. Okay, so we can have the BC equal YZ, right? And they keep this angle the same, right? You can see this is the BC, but I can also do another one. Okay, if I can do this one is isosceles, the isosceles triangle, doing the YZ equals BC, so triangle CBZ is isosceles triangle, so still possible, right? So that's why the Z and the C can may or may not be the same point. That's why. Okay, next. Okay, so what we have is the right triangle and right angle and right angle, right? So what we have is the XZY. So this is the this one is the angle bisector. Prove the and this one is AX equal to the XY. Let me use the color. Okay, AX equals the XY. Okay, and now you can see. Okay, so if AX equals XY, and let's still parameterize it. Okay, we want to prove the ZD is perpendicular to the AY. Okay, let's see if ZD is perpendicular to the AY. If it's true, right? You can see. Let's put a B here. What do you think? You can think the ZD is no matter the angle bisector, but also perpendicular. So what kind of the triangle of the ZYB have such properties? It's alpha alpha, and you need a perpendicular. Of course, you need to prove this one is an iso triangle, right? Okay, so as long as we can prove the BZY is an isosceles triangle, we prove this. Okay, now let's see. Let's parameterize all those angles. Okay, let's see. This is the beta. This is the beta, and this is the 90 minus beta, right? So of course, did you see the triangle AXB is a right triangle? 90 minus beta. So this is 90 minus beta. Okay, now we see the angle ZBY is equal to angle ZYB is equal to 90 minus beta. Then we can see triangle BZY is isosceles triangle. Then you can see the and also the ZD is angle bisector of vertex angle, right, of angle Z. Now based on this, you can see that ZD is perpendicular to AY. Okay, that's it. Next. So still erected. So you see the erected basically the erected construction, okay, has many good properties. Okay, you can erect it also equilateral triangles, and we can erect it with the square, and there is many things like the collinear proof questions, or we can see is the collinear or the concurrent. Okay, collinear means, I mean, you prove all the points A, B, C are on the same line. Concurrent is you prove the three lines intersect at single point P. Okay, there are many ways, good properties about this erected constructions. So now let's see. Okay, so let's do it. Prove the AP equals, okay. So the AP, BQ, and CR, if you want to prove it, still you need to put into the congruent triangle. Okay, let's see how we can do it. Let me using some color. So let's see the AP first. Okay, AP and the CR. Okay, now let's change another color. But you can see, right, something, you need to use another equal size, right? So you can see the BP equals CP, right? This is the second size. This side's connected to the CR. This side's connected to the AP, right? And the third one is AB and BR. Okay, did you see it? Okay, now you already find the two sides are equal, right? Let me see. So you already find the triangle CBR and the triangle the PBA. You already have the CB equals the PB, and you have the PB. Then you have the RB equals the AB. then we try to, let's see the angle of the RBC and the angle of the ABP, right? So this angle is equal to the 60 degrees. RBC, this is the 60 because equilateral, right? 60. Let's see, this angle is B, right? So this angle is plus B. This angle is also 60 plus B. They are equal. So these two triangles are what? Are congruent, right? These two triangles are congruent. So you have the CR equals AP, okay? So you have the same, you can do the same thing, okay? For another triangle, you can use the AP APC, right? You can use APC and the and the BQC, right? So the same thing, you can use the APC and the triangle let me see, APC, okay, and APQ BQC, right? You can also prove this. So this way you can prove that BQ equals the AP. Then what do you have? That means they are equal, okay? Next. Okay. So this one, we already talked about it, right? Let's see. That means the angle A will be the 40, right? So AB is 13. Then BC, right? So BC is the 10. So let's see, this is the 10. Okay. So, but we have two B's, right? This is the two C's. This are called C1. And I can also do this, right? This is also 10, where I call C2. The question is, what is the two possible values of B, right? So we can have this one is the alpha, and this one is beta. So the first B from the triangle ABC2, right? So first B is beta. The second B is from triangle ABC1 is equal alpha plus beta. So the goal is to solve alpha plus 2 beta. Okay, so let's parameterize it. Since we have a triangle, this one is 10 and 10, right? So this is the C2C BC1 is an isosceles triangle. So we can parameterize this one is 90 minus alpha over 2. This one is 90 minus alpha over 2, right? So, and you can see this angle is the external angle of the AC2B, right? So that's why the 40 plus beta is equal to 90 minus alpha over 2. Then we can see the alpha over 2 plus beta is equal 50. Then times 2, you can get alpha plus 2 beta is 100. So this is the question ask you. So yeah, that's it for this chapter of the geometry. Thank you. Bye bye.